Hello, everyone. Welcome to Math 135, Coronavirus Edition. Just so you know, for this week and next week, I decided to record our lectures, and then that way you can watch them at your own time, at your own convenience. What will happen is each class day will have a lecture, and then there'll be a worksheet. You'll then need to print off that worksheet or work on it on a tablet and then scan it in. I'll have some more instructions about that later. So I hope that you're all doing well and that you're making the best of the situation. I know it can be hard to stay focused when your routine's been pretty, badly thrown out of whack, but I'll be praying for you during this time. So a couple reminders, there is still WebAssign due on Friday. That's over material we learned before spring break. And I've already mentioned the worksheets. So let's begin. So I'm going to switch over to our PDF for the day. This has the notes that I'll be showing you. All right, here are the notes. You should be able to see them now. So here is what we're talking about today, section 7.4, which talks about central tendency. So we're going to go over some definitions that you've seen before, but it's a good refresher for where we are in the class. Feel free to pause the video if I ever go too fast. So the two things that we are most concerned about in statistics are statistics and parameters. Statistics are numerical descriptions of data. So you have seen lots of these before. Some examples are the sample mean, the sample standard deviation, the mode. These are all examples of sample data, which are called statistics. Well, why do we care about them? We're trying to understand the parameters of a population. You really want to understand, well, what does the population mean? What is the population standard deviation? To give you some context, let's say we want to know the average height of all students at Lee. We can't actually do a study that surveys every single student at Lee, so we have to take a sample and we get a statistic from that. The whole point of statistics in our class is to take what we know about statistics and understand what we can about the parameters. So I'm going to show you a page that will describe some of the different parameters and statistics that you've seen so far and the notation that we use. So some of these values are the sample mean, which we see at the top of our list. We see the sample mean, and we use X bar to denote the sample mean. The population mean is denoted by the Greek letter mu. And what you generally see are we use English letters for the statistics, and we use Greek letters for the parameters. These are the ones that we're going to be dealing with in this course, the sample mean and the population mean, the sample variance and the population variance, the sample standard deviation and the population standard deviation, the sample proportion and the population proportion. So, well, why do we even have this field of statistics? Well, as you know, the population parameter is fixed. It is a number that does not change. If I want to know what the population of all Lee students is, when I look at their height, that height doesn't change. However, if I take a grouping of 5 students, let's say the 5 students in my 12 o'clock class, and I take a sample of 5 students in my afternoon class, they're going to have different average heights. And therefore, the statistic will change depending on the sample. So unfortunately, we're in a world where we only get to use statistics to understand the parameters, but fear not, we can understand a lot from them. Okay, so what is the point of our class? The class is to take our sample data and say as much as we can about the population. And we do that through 3 ways. The third way on this list, regression, we've seen before. In this type of inference, we try to make estimates based on the value of a certain variable. So we've seen regression already. The two that we have not seen are estimation and hypothesis testing. You might have seen these before in high school if you did it, and we should get to both of these by the end of the class. These are the main ways in which we try to take our statistic and understand something about the population. I won't belabor that point too much because we're going to talk about it a lot as the class goes on. So, what is it that we need to know before we can do estimation, before we can do testing? There is a type of distribution we need to understand, and this is called the sampling distribution. It's the probability of a sample statistic. So what does that mean? Well, you're going to see what that means through a little example that we're going to do with dice. So the sampling distribution is the distribution of the statistic, not the actual distribution. So let's give us an example so we can show you what I mean. Let's do it with dice. So let's switch over to this lovely website called random.org. This is what you'll be using for your worksheet. And we're going to roll 16 dice. And that's a random sample. And let's count how many 1s, 2s, 3s, 4s, 5s, and 6s we get. Well, it looks like I have a 1, I have a 5, a 6, a 2, another 6, 2 1s, a 5, 2 1s again. I have a 3, a 6, a 2, a 4, a 5, and a 1. So that should be 6 1s, 2 2s, 1 3, 1 4, 3 5s, and 3 6s. That's pretty varied. So let's go and graph this with a histogram. All right, so here we go. We're going to graph this with a histogram, and we know that we had 6 1s. That should be this bar right here. So we graph a bar with height 6. Since our rolls had 6 1s, we had 2 2s, we had 1 3, 1 4, we had 3 5s, and we had 3 6s. Okay, so that histogram is a little bit all over the place. We know that if we rolled lots and lots of dice, it would be relatively flat. It should be a uniform distribution, but that's not what we had today. Okay. All right, now let's redo this. So this did not involve taking any sample means. It didn't involve any sample statistics. So let's look at a slightly different example where we're going to roll 2 dice at a time and average them. So let's see what that looks like using our lovely random.org site to these dice rolls for us. So we're going to roll the dice 2 at a time, and we're going to do this 16 times. I'll do the first couple, and then I'll spare you the details, and I'll show you what we got. So we're going to roll 2 dice, and we're going to average them. So the average of 6 and 2 is 4. We can roll again. We average the 2 dice. The average of 6 and 4 is 5. We roll it again. The average of 3 and 1 is 2. And I'll do a couple more before I just do the rest of them. The average of 1 and 5 is 3. And last but not least, the average of 4 and 2 is 3. So I'm going to compute 11 more of these, but I will spare you the details. All right, so I've finished my dice rolls, and we're going to go back to the whiteboard where I was working before, and I'm going to record all of the dice rolls that I had. So let me do that now. All right, so what do we have here? We have all 16 of these rolls, and we're going to plot them on the histogram. So we see that we have 2 that have leading digit 2. We have 1, 2, 3, 4, 5, 6, 7 that have leading digit 3, 4 that have leading digit 4, and 2 that have leading digit 5. So let's graph this. 2 here. We had 1, 2, 3, 4, 5, 6, 7 that were in this category. 4 in this category, in the category 4. And we had 2 right here. So I want you to pause the video for a second and think about, how does this compare to the previous? So if you look at the previous histogram versus this one, you notice that it's all over the place. But this later histogram is much more concentrated. And this is not a coincidence. You would expect when you take 2 dice and you average them, it kind of makes extreme values less likely. And this is a behavior, a property that you're going to see carried out today and on Friday. So that's the main lesson that I have for today. What I want you to do now is to do this experiment as well using the same website. So if you go on Moodle and you click on today's lecture, you can see the following Word document. And this is the document that has today's activity on it, where you'll be simulating dice rolls of your own. The top part is the probability distribution, and the bottom part is based on average rolls that you'll calculate below. So you'll want to print that off and then fill that in by hand and then re-upload it. Now, when you upload it back to Moodle, I want you to use a certain scanning software that you can get on your iPhone for free, and details about that are on the Moodle assignment page. So last but not least, the website that you'll be using in order to use your dice rolls is random.org/dice. And you'll use that to help simulate the dice rolls. Or if you want to use dice rolls of your own with dice at home, that's fine too. Let me know if you have any questions, and I will get back to you as soon as I can. Email is probably the best way for me to get a hold of me during break, but I'm going to try to have some office hours, which I will let you know about soon. All right, get that worksheet in, and let me know if you have any questions. Take care.